Hi, this video is to talk about test of significance in multiple linear regression. This is chapter 15 of our book, Anderson book, Essentials of Business Statistics. And just to tell you that in the previous classes, in the previous video, what I showed you is the Butler Trucking Company example case to discuss about using Excel. Let me show you here to get the raw data and then find the coefficients here. Okay, we work on the coefficients. I interpret the coefficients. I came up with a regression equation using the coefficients. I use one example here to show how to predict the dependent variable, in this case total time, using dependent variables. I also showed you the coefficient of determination and adjusted coefficient of determination and the interpretation here. Okay, so I showed you many things. Now I'm going to show you the test of significance, and these are all like topics I covered in more detail, like the conceptual discussion I covered in more detail in chapter 14. This is the application in chapter 15. Okay, so let's talk about the test of significance. We have two tests of significance here. The first test of significance is the F-test. Let me show you. This is the F-test. Okay, F-test. And this is in the consideration of the ANOVA table. We have an ANOVA table. Let me reduce the number of decimal places here. Okay, so we have an ANOVA table, and this ANOVA table, remember from our chapter 13 that ANOVA table is like evaluating sources of variation in the data. Okay, so these are the sources. Just to remind you, we went over that in chapter 13 and 14, sources of variation. We have a source of variation that comes from the regression. What regression? This regression equation here. The regression equation of considering total time as a dependent variable of how much miles and deliveries vary. So this is our source of regression. So these sum of squares are coming from the adjustment, the feat of total time as a function of miles and deliveries. Okay, we can see here through this coefficient of determination that 87% of this total time, 87.63% of this total time is explained, is due to by variance in miles and deliveries. So this is like where this sum of squares of regression are coming from the equation. Okay, and then we have the source of variation, which are the residuals. Remember from chapter 14, I have some videos about that. There are some errors. In trying to predict the total time, we're going to commit some mistakes. We're going to commit errors because it's hard to predict exactly what is going to happen in the future using data from the past. So this error, the difference between what I predict and what happens in reality, is the residual. So this is also the error. So there is a source of variation coming from the regression. There is a source of variation coming from the errors. And remember that we have degrees of freedom. So the degrees of freedom here is the number of independent variables. We have two independent variables, miles and deliveries. So that's the number of our degrees of freedom. Then we have the residual, which is the total sample size minus two independent variables minus 1. Okay, in this case we sum to 3, 10 minus 3, 7. Okay, and the total, the degrees of freedom here is total sample size minus 1. Then if we divide the sum of squares by the degrees of freedom, we get the mean square. If we divide the sum of squares 2 by 7, 2.2994 by 7, which is the degrees of freedom, we get the mean square error. This is the mean square regression. If we divide 10 by 0.03, if we divide this number by this number, we get the F statistic, which is 32. And then we have to figure out what is the p-value. So this is p-value. Remember the rule, if p-value is if p-value is smaller than the level of significance, which is alpha, we reject the null hypothesis. What is the null hypothesis here? Let me tell you what the null hypothesis is. So let me insert one more. So the null hypothesis is that there is no relationship between y and all x's, which is all there is no relationship between the dependent variable and the independent variables. In this case, we can interpret the dependent variable as the total time and the independent variables as miles and deliveries. So there's no relationship between total travel time and miles and deliveries. What is the alternative hypothesis? So the alternative hypothesis is that there is a relationship between y and all x's. Okay, so we have and it's always, the ANOVA test is always about these two hypotheses, always, regardless of how many independent variables we have in the model. This is the model. The model has two independent variables, okay? So it's always, if we have three, there is no relationship between the dependent variable and all three independent variables and so on, okay? So we have these two hypotheses. We have an f-test, we have a significance value. This is the p-value. If this p-value is smaller than the alpha level, we don't have the alpha level here. And if we don't have, we always consider 0.05. So if the p-value is smaller than 0.05, we reject the null hypothesis. This significance, this p-value is way smaller than 0.05. So we reject the null hypothesis, and our conclusion is, so let me insert here, I'm interpreting, so because the p-value is smaller than 0.05, we reject the null hypothesis and conclude that there is a relationship between total time and at least one of the independent variables. Okay, so this is the interpretation here. And this is the test of significance for the ANOVA table. Okay, this is what we can conclude. If this is significant, then and if it's smaller than the alpha level, we reject the null hypothesis and conclude that total time is related to one of these two independent variables. The problem is we don't know which one. We don't know which one of these two independent variables affect the total time or is statistically related. Okay, so this is the reason we have, so let me go back to the slides. The F statistics is used to determine whether a significant relationship exists between the dependent variable and the set of all independent variables. Okay, now let's talk about the t-test. The problem with this ANOVA test is that we don't know which one of these independent variables are significant. So we solve this problem. Let me introduce some, insert some lines here. So we solve this problem by using the t-statistic related to each one of the independent variables in this result table here, in this output table, okay? So now we have a test of significance for each one of the independent variables, and also we have a p-value. Let's color this p-value with a different color. So we have a p-value associated with each one of these t-statistic, which is related with each one of these independent variables. So what is the null hypothesis? So let's start with miles. What's the null hypothesis here? The null hypothesis is that there is no relationship between total time, that's our y variable or dependent variable, and miles, which is x1. Okay, so that's the null hypothesis. There's no relationship between them. The alternative hypothesis is that there is a relationship between total time, which is our dependent variable, and miles, which is our x1 variable. Okay, so this is our null and alternative hypothesis for the independent variable miles. So what is the t-statistic? The t-statistic is equal to 6.182, which comes from here. The p-value associated with this is 0.000. So should I accept, or should I reject or fail to reject the null hypothesis? So because, again, how do I make a decision here? I have to know what the level of significance is, our alpha. We don't have any alpha in the problem, so we assume that it's 0.05. If p-value is smaller than the alpha level, which is 0.05, we reject the null hypothesis. So the p-value is smaller than 0.05. So we reject, let's put here, because the p-value of 0.000 is smaller than 0.05, we reject the null hypothesis and conclude that total time and miles are related. Total time and miles are related. Okay, so this is our conclusion here. So let's go back to slides and let's take a look. This is test of significance using the t-test. The hypothesis that bi, in this case, the coefficient can be b1, b2, b3. This I means which coefficient we are talking about is equal to 0. The alternative is that is different than 0. This null hypothesis is the same thing as saying there is no relationship between total time and miles, which is expressed by our b1 is equal to 0. Okay? And this one is expressed as b1 is different than 0. Let me put different like this, different than 0. Okay? So this is the math way of saying that there is no relationship and there is a relationship. If there is no relationship, it's 0, it's null. Okay? If there is a relationship, it's different than 0. So we use this test statistic, which is implemented in Excel through this t-stat, and then this is the rejection rule. Reject the null hypothesis if the p-value is smaller than the alpha level. Okay, this is if we're considering the critical value approach. I'm going to skip this because we don't have the critical value approach here. So I'm going to skip that, and then and that's the rejection rule. So this is a slide to show you the same thing that we have in here. The only difference is that in the slide there are more decimal places. Here are less decimal places. If I increase the decimal places, if I increase the decimal places, then it's going to be the same decimal places we have here. Okay, so I'm going to stop. Let me see if there's something else to show you. So let me just summarize. So in the last 2 videos, we used the raw data to get results and get the coefficients, set up the regression equation, predict a model, interpret the coefficient of determination, interpret the ANOVA test, and one of the t-statistics. Now you have the t-statistic also for delivery. It's the same thing for delivery, but I'm not going to do it. I'm gonna let you do it, okay? So that's the same thing. There is no relationship, there is a relationship, okay? The only difference is that we have deliveries instead of miles, okay? And the same thing, the same process, but now deliveries and x2, okay? And now I'm gonna stop here and let you practice, and then try to do that for deliveries, go through all this process. Thank you.